Hello, I'm Liao. So today we're going to talk about how we can create a store that allows us to do undo and redo. Right, so we have a store that stores our data and we can make changes to the store. So presumably you have history of the changes that you're making. And then right now what we want is that we want the ability to undo the changes or redo it after you click undo. Right, so here I have done a basic setup. I've created something like a mini calculator where I have an input field over here and I have an add button. So I can type a number and then I click add or add a number 10. And then hopefully I can type say 50 and add 50 to it to 60. So what I want to do is that this is implemented as a store and I want to have the undo or redo ability in the store that allows me to click undo and jump back to 10. And then redo will jump back to 60 because we created with 60 first and then undo back to 10 and then we jump back to 60. So to create this kind of stores. So how should we approach this? So that's what we're going to talk about in this video. So the thing about how we can create an undo redo store, right? We want to think about the undo redo mechanism, right? So most likely you will have an array that stores a history. And that history could be of two kinds, right? So that determines the two different approaches that we can look at for this video, for this problem. Right? So the two approaches will be, first is that we have a history, we have an array of actions. So that the history array records every action that you are making. Right? So hopefully when you do undo, it means that you are reverting that actions, right? So the action will probably have two different kind of methods, or maybe the action itself is designed in a way that can make changes to the store in one way, as well as reversing the changes, right? Advancing, like applying the changes and reversing the changes, right? So you have a array of that record. Then doing undo or redo will be as straightforward as applying the changes or reversing those changes, right? So that is one approach and we shall explore that later, but let me explain like a second approach. Right? The second approach will be the history array stores a snapshots of the value at every changes. Right? So every time when you make changes, you store the snapshot of the value that you're storing, right? So when you make new changes, you store again a new snapshot. So you have a history of snapshots of your value, the store value, and doing undo or redo will be reverting to that snapshot, right? So you'll be kind of like setting back the value of the store to a previous value, a previous snapshot. And then redo will be setting it to a new snapshot. Well, of course, the act of undo or redo shouldn't like affect the history itself, right? So doing an undo will be setting the store value to a previous snapshot, but that shouldn't set the store value in a sense where it's like setting a new snapshot, right? That is like just reverting snapshots. That's all. It doesn't touch the history of it at all. Right, so we're gonna explore these two approaches. This will most likely will be like a live coding kind of way of explaining things. So you will see like my thought process along the way on how I'm gonna tackle this. So I've laid down my two general approaches, two way of thinking of it, and we shall take a look at both of them. Right. So this video may be long, so I will try to put in some landmark in the YouTube video, so you will have like sections if you want to jump on the first approach or the second approach. Right, so before I get started, if you like this video or you think that this video is going to help you a lot, please consider to like my video as well as share it if you are at the end of the video if you think it's great. Right, so liking my video will definitely help me as well as you, because anyone who likes my video will give YouTube an idea that this video is great, and it will share and recommend to more people like you. And more people like you will able to see this kind of video and help them, right? And in return may help you, right? So let's see the first approach. So the first approach we're gonna do is so here we have a simple store where every time when I add something, we are actually changing the value of store, right? We say store plus equals value where we change the store, right? So what we want to do here is we want to add an array called a history. Okay, so remember this approach number one. I'm gonna create a new file called approach1.js. So this approach number one is we're gonna store a history of actions applied to the store, right? So okay, I think I should do it this way. I should import something from approach one. So this approach one, let's see, we're gonna use, let me think, how should I do this? Okay, so we're going to use a concept that I introduced previously. It's called a higher order store. So it's a function that sticks in a store and create a new store. So this store hopefully will gives you an enhanced ability to the existing store, right? So much like you learn about in JavaScript where you have higher order functions, which is a function that returns a new function. I'm probably taking a function and return a new function, right? So higher order store sticks in one store. So that store itself can be any kind of stores, can be a writable, can be a tweened store, can be anything, right? So we don't care about what is that store under the hood, but we just add, we're just gonna wrap this store and add two more abilities, which is to do an undo and redo, right? So here we're gonna export this function, which is our higher order store function. I'm going to call it approach one, right? So it takes in a store and hopefully it returns a new store, right? So a store is a normal object. Any object can be a store as long as it follows the Svelte store contract, which is to have the subscribe function that takes in a function and return an unsubscribe function. And the function will be called with the store value, right? Every time when it's changed, the function should be called to notify all the subscribers that a new value has changed, right? So you have to follow the store contract, which we're gonna implement store contract over here. Okay, so here we're gonna take it up. We're gonna import approach one from approach one, and here we have our store, right? So we're just gonna make this store a undo redo store, right? So we're gonna create. We're gonna say undo redo store. It's gonna be approach one, wrap around with our existing store, and hopefully this function will return us a new store with the same store ability, but with two more functions, which is to do undo and redo. So we're gonna use this undo redo store instead. So everywhere here we're gonna just use undo redo store, and over here on click for undo and redo, we're gonna call undo from the undo redo store and redo, right? So we haven't implemented the store contract. That's why it says that undo redo store is not a store with a subscribe method, and we're gonna implement that, right? So first thing first, we can still use the underlying store subscriber method over here. So subscribe can still be the store subscribe. Okay, and set is something that we're gonna override, right? Set value. Okay, and then we have the undo function method and the redo method over here. Okay, so first is we need to have a history to store a history of actions that is going to be applied to the store. Right, so I'm going to create this history array. Okay, so now we are doing a history of actions applied to the store. So which means that we right now, because of this design, we can't do this undo redo store plus equals value anymore, right? Because if we just do this, we're setting a new value to the store, but we didn't tell the store that how we are going to do a reverse action of it, right? So of course there's a lot of ways to so we can't really do, we want to we can't write this straight away, but we're gonna write it in a way where, say, I'm gonna say undo redo store, and then I'm gonna call, let me think of okay, I'm gonna call it do action. So I'm gonna define a function called do action, which we're gonna have two methods, right? As I say, it's either you apply the action or you reverse the action, right? So it's apply or reverse, right? So apply and reverse. So do action. So now we change this to a method called do action that does that takes in a object that you will have to apply this. This object itself is like an action, right? Which is something that we're gonna store in the history. So it has two methods in this object, which is to apply something or reverse something, right? So say for example here this should takes in like the value of the store of this undo redo store. So apply meaning we want to, here we are adding, right? So apply is to add value, right? We're gonna return a new value of the store, so we're gonna add this value, and reverse it is actually gonna be subtract from it, right? So return is value minus this value from it, right? So you apply or reverse, so we have to do this kind of pair. Of course you are saying, wow, this is this is ugly, right? This way is a bit ugly to write this. So this is an action object that has two methods, right? Apply and reverse. And a lot of times if you look at libraries like or best practices of when you see how people use Redux and Redux like libraries, you see that they have a function that creates this object itself, right? So that function kind of abstracts away a bit of this ugliness and makes it more easy to, every time when you want to add value, it's not gonna write like this object, right? So this is an action object, and the functions usually is being called an action creator, right? A function that creates that action. So I'm gonna create this function just to show you how that function usually look like. So we're gonna call sum, right? Which sum takes in a value. So this should create this object, right? So I'm gonna create this object. So this value comes in over here, right? So so to call this, we're gonna call do action and sum with the value, right? So hopefully this looks less ugly-ish, right? I guess we have problems with having a gonna call, I think this is a bug from Svelte that does not allow dollar value in an argument, right? That's just me remove it. Okay, so this function returns a object, right? So we're gonna call this to return us that object. So this is the action creator. We're also gonna add this in the comment. Action creator. You probably will see this kind of action creators a lot. People think it's a boilerplate kind of ish, I think. But here we want to, because we want to have like two methods where we will apply changes and reverse the changes. Probably we're gonna have to create this kind of object that we're gonna push it into a history. So this is something that we kind of have to do, right? History of actions, right? That's what we're gonna have. Of course, you can't hide this somewhere else, right? You can have maybe like storing this part of the definition of the store itself, and then maybe over here instead of do actions, you call like the sum of value, something like this, but having like this action is defined ingrained within the store itself, right? So the store kind of know that, okay, it has a function that calls sum that actually does that, pushes this object, this ugly object here into the history, right? So over here we can do something more generic. We're gonna say just like do action and push the whole action into the history, right? So it's about the boundary of where you abstract things out, whether you keep more push more of that detail into the store itself, or maybe just like expose have a more generic and expose that option to the user, right? So here we are calling do actions. So maybe do action meaning we are going to have a do action method instead of value, and this is not value anymore. This is actually action, right? We're gonna do this action. So first thing is we're gonna push this action into the history, right? So we have a list history of actions, and of course we want to do this action, right? So we're gonna say action dot what's that, apply, action dot apply, and we're gonna apply the store value, right? So what's the value of the store? Well, we will have to say import get from Svelte store. We get the value of the store. Right? And then this will returns a new value, new store value. And this new store value, we're gonna set it back to the store, right? Store.set new store value. Because this is a lot of line of codes and maybe slightly unoptimized, because every time you get store, when you use get, it's what it does under the hood is trying to subscribe to the store, grab the value, and then unsubscribe from the store, right? So we can work around, or we can have a much concise way of actually expressing this, right? Which is to call store.update the store value. Okay, so this is the value, and over here we are calling action to apply with that value, and we are returning immediately. So returning immediately, which is to set this return value as a store value, right? So this replaces these two lines, right? So we don't even need to do the get over here, right? So we have history.push, and now undo is nothing but history.pop to pop up the action. Okay, and we have this. So we pop up the action. We're gonna do is action dot reverse, right? So we're gonna copy do this line, store the update, by using store.reverse instead of store.apply. So I'm gonna copy this. Okay, so let's try this out, right? We're gonna add 10, we're gonna add 20, we have 30, so we have, and then let's add 30 to get 60, right? So we start from 0, 10, 20, 0, 10, 30, 60, right? When you click undo, we jump to 30, and undo, we jump back to 10, undo, we jump back to 0. Okay, so a great thing about using the higher order store is that instead of having to just use writable, we can have actually tween store, Svelte motion. Whoops. Tween store, right? So now we can add 20, we can add 30, and we can still do undo, and undo, right? So we don't really care what's the underlying implementation of a store. It can be a tween, it can be a spring store, it can be writable, anything. You depends on what you want. But the key is we are adding this undo redo ability to your store that allows it to change the value, right? However, if you right now if you want to implement this redo, you realize that it's not as straightforward as it is anymore, because we pop out the action, right? We pop out the action, meaning the action is no longer in the array. So right now, if we want to do a redo, we want to do a redo. What are the actions to redo, right? So meaning we can't really, when we do undo, we can't really pop it out, because if we pop it out, this action will be used and then discarded after this action, this methods, and we're no way to redo it unless we maybe collect this undo action, right? But a much easier way to do this is actually maintaining a index, like what is the 0. So what is the current index, which is what is the current history, right? So it starts with 0, and the history itself should actually start with the current value of the store, right? So here we're gonna just get the first initial value when we create this new approach one undo redo store, right? So let's add back the get. Okay, so here when we do action, what we want is that we want to forward this index, and we say history index is equals to the action, and we're gonna get this one, history index dot apply the value, right? So undo would be actually decrement the index, history index, and then again same thing, history index to refer to that action, and then reverse it, right? And then redo is actually to increment again, back again, and this time around is to apply it, right? Apply that action. Of course, there's one thing we kind of need to take care of here, right? So when you do undo a few times, and then you do when you want to make a new changes, you actually want to discard the rest of the undo, whatever is undo. You can't do a redo anymore, right? You want to remove all the undo actions. Right, so that is what we need to implement it. But before that, let's just try this out first. Right, so we add 10, we add 20, we add 50. Right, we undo back to 60, undo back to So something is wrong over here. Let's see what's wrong. So okay, reverse is not a function. So I think we need to check if we greater than 0, only we can do undo, right? So I think this is not a start. We need an action, right? So sorry, I have no idea why I wrote that line. Okay, so while we still have it, we just keep increasing. Hey, this one should just start with -1, right? So index 0 and then an action. Okay, so greater than 0, while we still have something on the history array, we just decrement and then apply that. Okay, so let's start with 10, reach 10, and then it starts with 20, reach 30, and then 30, reach 60, right? Undo will, okay, undo should bring us back to 30, and then undo should bring us back to, something is wrong over here, right? So let's take a look again. 10, and okay, let me change back to a writable. So let's start with 10, and then 20, and then 30. Right? Undo should be, okay. So we should, okay, I think I got the logic messed up. Okay, so here we are, while we still have history, right? Greater than 0, right? Greater or equal to 0. We apply the current action, right? Because the current action is the one that is pointing at the history index. We could apply the current action as the reverse and then decrement the history index, right? So yeah, so if you are at 0, you apply that 0 actions reverse methods and then you decrement to -1 and then therefore you can't do undo anymore, right? So you have 10, 20, 30, undo is 30, undo is 10, undo is 0. Okay, that's right, correct. So if we do redo, again we should apply the current, let's see. No. So redo is, because undo will move the index back, right? So redo is we're going to move forward and then apply that action. So we're going to say, move forward and apply that action. But we have to make sure that if history index is less than history.length minus 1, right? So because the last index that you can get is history length minus 1, right? So if the most you can increment is to that place, right? So if you're less than that, you still can increment. Okay, so 10, 20, 30, right? Undo is 30, undo is 10, redo is 30, redo is 60, and then you can't do undo or read. Yeah, can't redo anymore unless you undo, right? So what I said before that, before we train out and fix things around, is that when we do action, we also make sure that if we have undo previously, we want to remove all this undo history if we do a new action, right? So what I mean is that, say we redo is 60, right? So you undo 30, but right now if we add, say 40, we should not allow any more redos, right? All the redos should be nullified, right? So in this case, what we're gonna do is, once we increment or apply an action, we should also add another check, which is to remove everything, all the history index above, all the history beyond history index, right? We remove all the past histories, right? Of course we can override this, but then whatever is beyond that is going to be nullified, and thus we don't allow any redos anymore, right? So say for example, if I do add 10, 20, 30, and we do undo, and then we apply say 20, right? So now if you do redo, it jumps to 60, which doesn't really make sense, right? Because 60 was like the undo, redo, right? That the last redo, but then we undo, and then we apply a new action, then we shouldn't be a redo again. So here we're gonna remove them, right? So we're gonna do for loop, a very simple for loop to go through everything and remove everything. I think I'm just gonna use instead of for loop, I'm gonna use a while loop to say while, okay, I'm gonna say let's I equals to history index dot index plus 1, right? We're gonna remove everything. Okay, no. So while say history index is less than the history dot length minus 1, right? So this means is that this line says that history index should be the history length minus 1, right? If you are less than that, meaning we have still a lot of histories in the history array, we should remove them. The way of removing is going to say history.pop. It's going to pop out from the end of the array, right? So while history length minus 1. Yep, correct. So let's try that out. So we add 10, 20, right, 30. Could undo twice, back to 10. Gonna add 50. And now I can't do redo. Oh, wait, you can't tell the difference. Okay, hold on. Let's restart everything again. So gonna say start with 10, 10 again, and 10 again. So we have 10, 20, 30. Undo, and then now we're gonna add 80, right? So if this works, I should not redo back to 30, right? So yeah, if I click redo, nothing happened, but undo will bring us back to 10 and redo bring us back to 90, right? So here we have our first approach number 1, which is to store a history of actions. An action is nothing but an object, right? It's nothing but an object that has apply method as well as a reverse method, right? So we have this kind of object with apply and reverse. We store them in an array of history as a history. So every time when you want to undo, it's gonna be calling the reverse method, and you want to make changes, you're gonna call the apply method, right? So undo is reverse, and then redo is apply again, right? So you store this history of actions, and there you go. There you have a history undo redo kind of store, right? And we say that creating this object, these actions is a lot of boilerplate. Then maybe instead of like having to create this object every time, maybe you create a function that's called like action creator that creates that action for you. And maybe this makes the code more slightly concise and easy to understand. And you could define this action right inside this store itself. Like say maybe have like maybe like adding this whole thing like sum in here. We're calling sum is to pushing history, which is to do like this dot do action, like to do this action itself, right? You can have this built into the store, then you'll be able to just like calling the sum itself instead of having to call like the do action, right? You can do that. You can do that. It's up to you on how you designed your store, like how you abstract out the functionalities of your store, right? So we've seen how we can do the approach 1, which is to have a history of actions. Let's explore approach number 2, which is how we're gonna have a history of store values. So if you like how I approach the approach number 1 so far, don't forget to smash the like button, because that is very important. As I said, it's important to you as well as me, so that we all know, YouTube knows that this is a good video, and you will try to promote more to more users, so that they all of you will enjoy and learn more together and grow together, right? So let's take a look at approach number 2, approach 2.js. Same thing, I'm gonna create a higher order store. So I'm gonna copy some of the things over here. Of course, maybe we don't need this. All right, approach number 2 is to store a history of store value snapshots, right? So the way of implementing this will be every time when you set a new value, we are going to store a new value into the history, and every time we do undo is to reset set the store with the previous history value or whatever is the value inside that you store in the history stack. All right, so here first is we're gonna again create this gonna have the similar concept over here, history index. Here we're gonna store snapshots of the store, right? So I think the first item we can have in the store is the value of the store, the current value of the store. So history index right now is 0. Okay, the next thing is gonna have same thing. This is gonna be a store. I'm gonna copy some of the things that we've done over here. Subscribe. Okay, undo. Maybe we don't need this is to be determined, right? But the idea of history index is still valid. Redo, this is still to be determined, but the idea of not going over the array is still valid, right? So we have our new store, approach number 2. I think I should just copy this whole code over here and say app 1, right? So if you want to play with this REPL, you can look at the link in the description, right? So I'm not gonna modify this code. This is app one for approach number 1. Okay, so right now we're gonna import approach number 2, create a new approach number 2, undo redo store. And this time round, we don't need, we can't do this directly, right? Because we're gonna just set the value, right? Doing this is to call undo redo store with a .sets method to set a new value to the undo redo store. So the magic itself will lies within the set function, right? So here we have set. So let's write set. Okay, set will be called with a value. Okay, this will be the new value, right? So we want to store a history of values, right? So here, first thing is we say history index increment, and I say history of history index will be the new value. And now we want to set this value to our store as well, so that whoever is subscribing to the store, this return store is still using the same store subscribe, right? So the subscriber of this store will get the new value out of it. So we're gonna say store.set new value. Okay, so this is actually the same of writing this. We'll just do it like this for now, because later on you will realize that we are making a lot of this, and we hope we're gonna do this all over and over, and maybe we can make this into a function, right? Abstract this out, right? So for undo will be take a step back and sets the store to that previous value, right? So here we're gonna say history again, history minus is correct, but we're gonna do it while history index is greater than 0, because we're gonna take the value from history after we decrement, right? And we're gonna copy this because we're gonna set it back. And over here, redo will be playing the history index, right? So while history index is less than length minus 1, we increment it correct, and then we're gonna set the value of the store, right? So you realize that we're gonna do this over and over. Maybe we can make it a function. I'm gonna say update store. I'm gonna paste this in and gonna replace it over here like this, right? Place it like this. Okay, so we have all this, and of course one last thing that we did for the previous approach is that when we increment and we update the value, we also need to remember to clean up all the history, right? So what we did over there was to say, well, it's less than that, so we're gonna pop the history. All right, so we're gonna do that as well, and let's try this out. Okay, so we say 10, right? We have another 10. We have another 10. Okay. Now we undo. We're gonna jump back to 20, undo back to 10, and redo to 20, redo to 30, right? Undo, and we add 80. And now we can't redo anymore, but we can still undo, or redo, right? So there you go, have a history of values, like the snapshots of the values of the store. So before we end this, there's a catch on this approach, or there's a catch on both approaches depending on how you design the action of approach number 1, which is that what if we want to store, instead of storing numbers, primitive values like numbers or strings, we want to have a store that stores an object, right? What if we want to store an object? Why does that matter? Well, because object itself is mutable, right? You can mutate object, right? And oftentimes we are so used to in Svelte, we assign a value to the property of the object, right? To the store, right? That actually mutates the store, right? So so if you're storing a snapshots, I think that will mainly affect approach number 2, which is if you store a snapshots of the store, actually storing a reference to the store itself, right? And if you mutate that store object, the store value object every time when you changing it, storing a reference is actually storing the same reference over and over and over again. And in the end, you are not, when you want to try to redo it or undo it, you realize that there's no effect because you are still storing the same object reference, right? Because all along when you make changes, you are actually mutating the object, right? So to demonstrate this, let me show you what I mean, right? Let me change a bit on the code itself, right? Just make a very simple change. Let's just say writable is a value, it's an object with a value property, value 0, right? So here we gonna have two ways of displaying the value. So first is we're gonna stringify the undo redo star. So this shows us what is in the star itself right now, and here we are getting the value itself, right? So okay, so now we have the star value, right? So every time we increments, we need to +1 of the value, right? So technically, this is the changes that we just need to do, right? Because this line itself will still call the set method of the undo redo star to set the new value of the star. Of course, in this case, the star itself is the value of the star is not changed. The reference itself is not changed. The value inside it has changed, right? The star value dot value has updated, right? So let's see, right? So when we add this has changed. We add 10. You see that it counts 11. We add 20. It turns into 31. And when you want to undo it, you realize that it's not possible. It's not possible at all. So what is happening, right? As I explained, this is because everything within the history is still everything within the history is referencing to the same object. To just show you one more step that this itself is true, I'm gonna expose the history out. I'm gonna say this is a writable import writable from Svelte star, right? And so I'm gonna make history a writable star as well. I'm just gonna create a new history writable history star, and I'm gonna have a property called history that returns history star. And everywhere when we change the history, which is over here, only over here, I'm gonna set which is called history star.set history. Okay, so here we have it, and here right now we're gonna just have somewhere to show you the value of the star. G5. Okay, so this is the history, and this is a star, so I'm gonna say star. Okay, I'm gonna add a new line. So this is the history. When I add 10, realize that I'm pushing a new value to the history, but then because both of them are referencing the same star, the same object, both of them, the value has updated, right? If I do this, you realize that we are pushing another same reference into history. So undoing itself does not have any changes. It does not have any effect at all, right? So yeah. So what should we do? So one way is, I said we're gonna save the snapshots of the objects inside the history array, right? So getting a snapshot itself can be a very simple, straightforward way of doing it. Would be using the JSON stringify or JSON parse, a combination of both, right? So if we turn the whole star value into a string and then convert it back to an object, what you get is a new object of whatever the star value is, right? It's a new object, so we store that new object into the history. So every time when you make changes, it will not affect it will not affect the reference in the array, right? So so what we're gonna do here is we're gonna say JSON.stringify okay, I'm gonna create a new function instead. So sometimes this is being called as like cloning the object, right? A fastest way of cloning the whole object out, right? Which is to convert it to a string and return it, and then parse it again to return back the object itself. And of course, this has its drawback. For example, this has there's a catch on this clone function, which is it only works with object that has no cyclical reference. Because if you have a cyclical reference, stringify will not work, it will break. And also it works if the object itself just a plain JSON object. Because if you stringify, you can't stringify functions. All of them, functions, null, undefined, things like that will be gone, right? So you have your own drawback over here. And then lastly, of course, about performance, whether the performance is good if you have a very huge complex store, you want to stringify it and parse it again. Is the performance okay? Well, it depends. It's dependable, right? So I'm going to just show you like a simple, straightforward way of doing a cloning first, and then later on I will suggest some alternative of using the idea of immutability to reduce this cost. Right? Of course, immutability itself introduces some sort of cost, but then if you have a far more complex, big object that you want to get a that you want to not mutate it, then immutability will come in handy in that case, right? So firstly, we just do a simple cloning because our object itself is so simple, right? It's a value, right? It only have one property called value, and it's number, right? So here I'm just going to call clone the value of the star, and every time I push something into the history, I'm going to clone it as well, right? Stringify is not a function. Oh, sorry, my spelling. Stringify. Okay. Let's clear this. Okay, so let's try this out. So now I add a number, right? You see here, this is not mutated, right? Because we actually clone a new copy and store it into the array. And if we make changes again, hold on. Okay. I think this is okay. So we clone it and store it in history, but then when we call update store, we're actually setting the clone version, right? Which is not what and then if you mutate that clone of the clone version of it, you are still changing it, mutating it, right? So I think over here, let's see, store in history. Okay, so I think over here, update store. Okay, so the update store actually, okay, we don't have to, we don't have to store a clone version in history in this case, right? So of course, the first time we store the clone, so we are not changing the first history, right? But then after that, we are going to, every time when we store something, we are not storing a clone, we just store the change version, but we calling this the clone, right? So this is just not taking care of the place where we just call set, also taking care of the place where we do undo and redo, right? So every time we undo, redo, we are pointing back to the previous snapshots, but then we are giving a new clone to the store, the underlying store, so that whenever you change from the history again, you're not changing whatever is stored in the history. You're changing from the clone of the history, right? So let's try that out again. So let's say that's at 10, at 20, right? And let's add 30. So we have history of four items in the history. And do undo. We're going back to 30, undo back to 10, and we can even redo, undo, and we can even like change the value at 20. Sorry, should add 20. Undo and then add 80. Right, so this does not change the state that I was changing, right? It does not change this value 10 like just now, but it's created a new, it's actually modifying a new clone and then update and then push that new value into the history, right? So cloning an object allows us to create a new snapshot object that, because object is mutable and you can't, if you change the object, if you want to store snapshots of objects within the history, you have to make sure that each of them are a different reference so that you don't mutate the snapshots that you are storing in the history. So finally, as I said about cloning, I mentioned about the drawback in terms of performance, things like and I suggested that we are going to talk about immutability, right? Because immutability itself will allows us to immutably change the object, meaning when you make changes, you're actually creating a new reference of the object, you're creating a new object, and then we're going to store that object into the store and set, right? So in that case, we don't have to do cloning, right? Every time when you make changes, you actually create a new reference of the object, and you just store that reference into the store, right? So so you don't need to do a cloning, right? So the immutability part of the algorithm of the library, whatever you are using, will help solve that problem, right? So a very simple way of doing the immutability is to, instead of assigning a value directly, we're gonna spread it out, right? So we're gonna create a new object reference, and then value equals to the new value, right? Actually, the new value will be the value plus value, right? So this will create a new object reference and gonna store it in the store. In that way, you don't need a clone function anymore. You don't need clone at all. And if you try to run this, right, at 10, at 20, they are all different. You will always create a new object before you calling a set to the store, right? So here you will allows you to having a array of snapshots without mutably changing the store value in the history. Of course, you may ask me like, okay, how about using libraries like Immer.js and things like that, because writing this sounds easy if you have a very simple object, but it may get hairy if the object itself is humongous, right? If you have like a very nested object itself, then you have to keep doing this, and then maybe like a foo, and then you have to spread undo, redo, store.foo, and then you add, because you want to add a new value to the foo, and then if foo the bar, and then you have to spread it again and things like that. And in the end, it just makes the whole thing very messy. And you will just like to use Immer.js because that allows you to assign make changes more easy, more intuitively to just make changes, because Immer.js will give you the library itself will give you like a draft state where you can make changes to the draft states directly, and then you can commit stat and then apply and then return a new object reference. Right, so we shall take a quick look at how you would pair this with, say, Immer.js. So first thing is I'm gonna import produce from Immer, right? And actually I've created a video about how you can use Immer.js with stars, and yeah, you should watch that video if you're interested. Like, that will be a full length video about talking about Immer.js and Svelte store, right? How to make Immer.js into a Svelte store, right? But over here we're gonna do a much lighter version of it, right? So you have a function called produce in Immer.js, which if you come over here, how it works is that you can call a produce with an object, and it will give you a draft, right? A draft. The draft itself is actually the value itself, but the implementation of it is like, it's like a proxy to the actual object, right? So this object, right, the store value is an object, and draft is a proxy to that object. So changes mixed to it will be applied to it later on, and it will apply it in a way that it's done immutably without changing the reference of this, right? So you'll return a new object reference in this, and you're gonna assign it to the store, right? So here, every time when you make changes, you will just create a new store reference, right? So draft over here, because the draft is the object itself, we're gonna just say draft.value as equals to value, right? That is what we're gonna write. Let me make it nicer. Okay. Right, so this way is much nicer and simpler to write, right? I believe that you will agree with that. So let's try this out, right? Let's add 10. Okay, process is not defined. So because of how Immer.js library is implemented, I believe it's using like the process, right? So process variable, and it will be handled by your bundlers. But let's just define this first, and then so a quick way to define this would be going to the iframe that we are running this. I'm gonna just define this window.process equals to env, which is an object, I believe. Node env should be, maybe I'm just gonna say production. And this just need to do once. Process is not. Oh, sorry. Hold on. I'm not. Okay. Let's just not play around with that. Let's just define it ourselves. Import patch. I call this patch. Window.process equals to env. Node env equals to production. Okay, yep, I believe we fixed it, and let's try. Okay, find a full error. Okay, there's some errors while using with the draft, I believe. Let's see. Let's try again. Okay, it works. Okay. I believe we shouldn't return any value from that, so I'll just make it a void. So here you see we just make it this way, and now it's very simple. We just add something, always give us a new reference from this produce function, and now we can undo and make changes and redo, undo, redo, things like that, and it just works, right? So if you want to store a history of objects, of snapshots of the store values, then if your store value itself is primitive, then it's simple for you because you always store the primitive value. But if your store value itself is an object, than having so you would have to either one, clone it, so that always clone snapshots to store in the history, or two, make changes immutably, right? Don't mutate the object itself. So you can do it yourself by using spread or use libraries like Immer.js to help you to do that, right? So that's all from my video. Hopefully this long-winded video helps you and makes you to learn, understand more about store itself in general, as well as like concepts like higher order stores, and undo, redo kind of operations. And hopefully you learn a lot from this video. So if you learn a lot from this video, I hope you can do me a favor by smashing the like button, as well as share this video to your friends or colleagues who are still learning about Svelte, or is learning Svelte, or is using Svelte. Hope that this video will help them as well. So that's all for this video. If you remember to subscribe to my channel so that you get notified when the next one is out. So see ya, bye bye.